Okay, so what we're going to be doing today is we're going to be looking at concentrations of solutions. Um, so let me go ahead and title this Concentrations of Solutions. And before we start talking about concentrations of solutions, I think it's really important that we go back a little bit and we remember a little bit about what a solution is. We have talked about this before, but I think it's important that we bring back up. So when we talk about solutions, usually what we have is we have what's called a homogeneous mixture composed of a solute and solvent. All right. So let's kind of think of an example and identify again our solute and solvent. So let's say that I have a beaker. Here's my beaker. And let's say that what I do is that I fill it with a little bit of water. So here's my water line. We have all these water particles. The water, my H2O, this is going to be called my solvent. Let's say that what I do is that I go ahead and I drop some salt in. So I have a salt shaker. I'm not going to try to draw a salt shaker. What I will do is draw two little dots for NaCl. And let's say that I have those in there. So I have my NaCl. We have all these particles. It's an ionic compound, and so it breaks apart. And so what we see here is that this right here, what dissolves my NaCl, is called my solute. So my solvent is what dissolves my solute. So I'll put that off to the side. Solvent dissolves the solute. All right. So what we can do is we can think about this. And when we talk about concentrations, if you've ever gone to the grocery store and you have gotten like concentrated juice, like sometimes you'll go to the freezer aisle, you can get actually a concentrated orange juice. And what you do is that you add that concentrated orange juice and you add water to it to make your orange juice. Well, that concentration means that there's a lot of the solute particles. There's a lot of that, and you want to add solvent in order to dilute it. So first, let's identify some key terms, and then I'll give you guys some an example that you might see in a lab. So the first key term that we want to define is concentration. So what does it mean when I'm talking about concentration? And I kind of just gave you guys an example, but let's give you the actual definition. It is the measure. So measure, which tells us that this is a quantitative measurement, so it's a number. We're going to have a measure of the amount of solute dissolved in a given amount of solvent. So for example, if we kind of go back up to this example right here, what if I added 100, actually let's go 10 grams of NaCl and I dissolve that in 1 liter of water. So I have a given amount of my solute in 1 liter of water. What if instead I added 25 grams of sodium chloride in a separate 1 liter amount of water? These have different concentrations. One has more solute than the other in the same amount of water. So what we have is we have two separate concentrations. Now, based off of the concentration, we could actually call um, solutions by two different names. We can have a dilute solution and we can have a concentrated solution. So in a dilute solution, there is a small amount. I'm going to move this up of solute dissolved. In a concentrated solution, there is a large amount of solute dissolved. So based off of kind of my example that I gave up here, I might say that this is a dilute solution and this is a concentrated solution. I usually put concentrated as CONC just kind of to abbreviate a concentrated solution because this one has less solute, this one has more solute. So if we are just comparing the amount of sodium chloride that is dissolved, I can kind of label one of those as dilute or concentrated. Now, when we think about dilution, there's also a very kind of handy way to identify it. So what I'm going to do is I'm going to go grab some water and I'm going to show you guys a quick example. Okay, so what I have here is I have several solutions of copper 2 chloride. So I have several solutions, so I'm going to go ahead and kind of lay them out so you guys can see them without spilling. I have several solutions. Now these all contain the same chemical. They all contain copper 2 chloride. But notice the color change. Notice that we have one that is nice and dark, that's really pretty blue, and they slowly get lighter and lighter and lighter. This is actually one important idea when we talk about concentrations. A lot of the time, what we can do if the solution has a color to it is that we can classify the solution as being concentrated or dilute, or at least order them based off of their color. The more intense the color, like this one right here, the more concentrated the solution is. As the color gets lighter and lighter and lighter, we have a less concentrated solution, or we can say that the solutions get more and more dilute. So you can see that there definitely is a relationship between the color and the concentration of the solutions. Now, how can we mathematically talk about the concentration of a solution? What if we wanted to look at it and we wanted to identify really what the concentration of these solutions are? We know if we look, if I bring these back out, we know that this solution is more concentrated than this one, but by how much? How much more concentrated is this one than this one? So we need to apply an idea to it. And this is where we get the key idea called molarity. Molarity is the way that we will be talking about the concentration of a solution. So this is a concentration of a solution. When we talk about molarity, we have an equation. So molarity is represented by a capital M, and it is the moles of solute, so what you are dissolving, over liters of solution. Notice that my units for this end up being moles over liters. So let's look at this and let's kind of apply some mathematical ideas to our concentrations. So let's come back to here. Let's say that in this solution, we'll call this solution, I'll flip these. Let's call this solution A and solution B. We know that this one's more concentrated and this one's more dilute. And again, we know this just by looking at the color of the solution. But we want to calculate exactly how concentrated and exactly how dilute is it. So let's say that in this solution right here, let's say that they have equal amounts of water. So let's say that we have our water, and let's say that in each of these, I added 50 milliliters. Okay, so there's 50 milliliters, they have equal amounts of water, but what has changed is the amount of copper chloride. So let's say that in this solution right here, I put CuCl2, I put 0.65 moles. And in this solution over here, I put 0.25 moles. So we have different concentrations. So let's go ahead and calculate our molarity of each of these. Now, the first thing that I want to point out is that you do have to convert your milliliters into liters. So that's really important. So this is not 50 milliliters, but this is 0.050 liters. In order to get from milliliters to liters, you want to divide by 100. 0.050 liters. So when I put this into my formula, molarity is going to equal my moles of my solute, which is my copper chloride, divided by my 0.050 liters. And then I'll do the same thing over here. My molarity equals 0.25 moles divided by 0.050 liters. And so now we can calculate this out. Let me grab my calculator. And we have 0.65 divided by 0.05. I have the number 13. And then 0.25 divided by 0.05, I have 5. So notice that now we can actually look at the concentration, and we could say that this is more than double as concentrated as this one. So what you're going to do from here on out, or next, is you're going to be watching the video that I have posted on for Edpuzzle, and it's going to go through another example of how to solve these molarity problems. I hope you guys have a great rest of your day, and I will see you guys in class on Friday.